Guys, this is the second video on our area approximations. So we'll be using a different method, midpoint rule. Okay, so we'll be discussing the midpoint rule. We'll be discussing the midpoint, how to handle questions on the midpoint. Okay, the midpoint rule. Midpoint rule. So in the midpoint rule, we are told what's the area calculating our area. We are trying to calculate the area of curves or area of any integral using the midpoint rule. So for example, the formula, straight away go to the formula. We can derive the formula using the Riemann sum and whatnot, but I'll just go straight. So the area using midpoint rule is approximated to be delta x. In my previous video, I showed how to calculate delta x into y naught, okay, plus all the values of y, 2 plus y to the n minus 1 plus y to the n. Okay? So this is how we calculate the midpoint rule. So this is the formula. When calculating the midpoint rule, it says delta x multiplied by 1, y naught plus 1, y1, y2 plus all the terms. So straight away give an example. So we'll talk of an example. Example. We are told find the area. Find the area given. Find the area of the following integral given by the following integral. Okay, so it will be the area of 2x cubed from 0 to 8, again the x. So we are told to compute this. How does the graph look like? Okay, so the graph looks like that. So that is the graph. It surely looks like that. Okay, sorry. The graph usually looks like something of the sort. Okay, so the graph usually looks like that. That's the graph where y equals to 2x squared to 2x cubed. Sorry. So that's our graph. This is the y-axis, this is the x-axis. Okay. So we're trying to find the area. The bound is from 0 to 8. So it's from 0 to 8. So we'll just find the area of this curve. Area for this curve. So the area required, the shaded region, is the area we require. So at first we said delta x. We now have to compute delta x. Okay, and same as b minus a divided by n, which is the same as 8 minus 0 divided by the value of n is usually given. For this case, I will use the value of n to be 4 again. Okay, so I'll just divide by 4. So my delta x will just be equal to 2. Okay, so from there, let's compute firstly the exact area. So the exact area, okay, is integrating this. It will be 2 divided by 4 x to the fourth, right? Then placing the bounds from 0 to 8. Okay? So the exact area will be a half multiplied by x, that is 8 to the fourth. Okay? This value minus a half multiplied by 0 to the fourth. So I'll get my answer is 8 to the fourth. Just write 8 squared. Again, I'll square the answer. It's 40. Okay, multiplied by so the answer multiplied divided by 2. I'll get my answer is 20. 48 square units. This just remains to be 0. So my answer is 14 square units, right? So I'll just calculate, let me write my exact area exact to be 48 units squared. Okay? That's my exact area. So allow me to clear this. Allow me again to clear. Just keep all the information in mind. Keep all the information in mind. Just clear that. For some space. Okay. Just clear. Knowing everything we know. Remain with the formula. So we found our area to be, what's our delta x? We found it to be 2 into what? Let's compute these values, the y value. So first we draw in x-axis. Draw just an x-axis, just usually a number line. Okay. Just a number line, but in presence it's an x-axis. So our graph, as you say, this was the graph. Let me draw again. Our graph was from the x-axis. Our graph was opening up like that, something like that. Something like that. So our graph said from 0 to 8. So this was the area, the region required. Okay. So our interval, we said delta x is just the interval of the area. So the first triangle, the first rectangle that we'll be creating. So the interval it will be from 0 to 2, 2 to 4, and so on and so on. So it will be from 0 to 2 to 4 to 6 to 8. Okay? So when computing midpoint, we usually consider the mid part of the interval. So this is the interval delta x. Delta x is equals to 2. So the midpoint is here, and here, here, and here. Okay, will be clear. So the midpoint for this will be 1, 3, okay, 5, and 7. So let's compute our first y naught, y2, y3, and so on. So our y naught, okay, is where we say the function graph was the function of the graph was y equals to 2x cubed, right? So that's our function. So we usually say our first y naught is where this is. Now we get our y naught from here. Our y naught, our y1, our y2, our y4. Okay? So our y naught, first value of y is where okay? So our first y0, the value of y0 is where x equals to 1. So it will be 2 multiplied by 1 to the cube. Our answer is 2. Our y1 is where x is equals to 3, so it will be 2 multiplied by 3 squared, 3 cubed, it will be 54. Okay? Our y2 is where x equals to 5. Okay? 5, so it will be 5 cubed equals to this one, 25. I think it's 250. Okay, let me just be sure. So it will be 5 cubed multiplied by 2. Yeah, 250. So our y3 is where x, sorry, this was supposed to be y3, is 7. So it will be 2 multiplied by 7 to the cubed. What will be our answer? 7 cubed multiplied by 2 will get 686. Okay, so from there, let's just approximate our area. We say our area, okay, midpoint, it's kind of easy. 2, that's our delta, into the value of y0, 2 plus 54 plus 250 plus 686, right? Quite easily done. So it will be 2 into, we just compute this. So it will be 56 plus 250, okay, plus 686. So I'll get 992. So I'll multiply that with 2. I'll get my answer as 1984. Okay, square units. Okay, so this is our answer. From here we can see the exact area was 2048. Okay, so this is the approximate area is 1984. So we have calculated some errors. There's an error involved in that approximation, so we'll try to find, using calculation of error bounds, the value of the maximum error that we are allowed to create. Okay, so there's a maximum value of error we are allowed to create. So we'll just calculate that. And just calculate, so we go to the error bounds. Error bounds using midpoint rule. Okay, so we'll have error bound involved in midpoint rule. So this is the maximum error that we'll be calculating, the maximum error that we are allowed to create while approximating the areas of curves using the midpoint rule. So the error we shall say the error, okay, involved using a midpoint rule is calculated as, okay, it's less, it's usually less, okay. Okay, let me try to explain that. The error found, it's usually less or equal, okay? The value of k into b is just the same as the midpoint, as the trapezoidal rule, minus a to the cubed divided by n squared. But now, in the trapezoidal rule, it was 12, so here it will be just 24. 24. So this is the formula. So let's calculate the error involved in midpoint rule when estimating this approximate area. So it will be greater or equal, less or equal to, what's the value of k? Again, here, the value of k is calculated just the same as my previous video on trapezoidal rule. We say the value of k is calculated when finding the absolute value of the second derivative of value of x. Okay? is less or equal to the value of k. So let's compute that. So we said our function was y equals to 2 to the x cubed, remember? So our y1, our first derivative, it will be 3 multiplied by it will be 6x squared. Our second derivative will be 12x. Okay? So this will be our 12x. So let's compute the values of k. So we usually have two values of k. So we have k1, where k1 we substitute, the bound was from 0, the bound was 2x cubed dx from 0 to 8. So the bound, we substitute the first value of x to be 0, so it will be 12 multiplied by 0. Okay? The second value of k2 will be 12 multiplied by 8. Okay? This will be 96. This will be 0. So what will be our value of k? We usually take the the maximum value that we usually get from these two. So for this case, our value of k will be 96 instead of 0. Okay, so we usually take the maximum value of. So our k will be 96. So the value of k there will be 96. Having that in mind, we'll write. Okay, let me clear this. Having that in mind, we'll write k96, okay, into 8 minus 0, that is just simply 8 raised to 3 divided by 24 multiplied by n squared, that's 4 squared, it's 16. Okay, so we'll get our answer as 8 cubed. Okay, let me compute that. 8 cubed multiplied by 96. Okay, so we'll get our answer as 152 divided by 24 times 16, 384. So our error bound would be 49,152 divided by 384. So our maximum error we are allowed to create is 128. So this is the maximum error we are allowed to create. The maximum error that we are allowed to create. Beyond this, the approximation is wrong. So let's find our error. Our error will be 2048 minus 1946. Let's see if it's within the range. Less or equal to 28. 128. So it will be 2048 minus 1984. What's our answer? The error that we have created an error of 64. Okay? And you can see it's less than 128. 128 is the maximum error that you are allowed to create. Beyond that, wrong. So we have created this error. This is the error we created. So it's within the range. So that's how we can think the error bounds involved in midpoint rule. My last video will be talking on Simpson's rule and how to compute the error bounds again using an example. Then my last video we talk of an example dealing with midpoint rule and how to calculate the error bounds. Don't forget to like, share and subscribe. Thank you.